Okay. So let's verify. Let's verify this identity. Um, you can pause it and write it down. I kind of got a head start on you. But looking at this thing, a couple things. I mean, I see a half angle here. Okay, that kind of since this is the section on half angles, I'm kind of inclined to think I should start there. Then I've also got this binomial that I could possibly expand if I needed to. I'm not exactly sure what I'm going to do yet, but let's just get started. I feel inclined to start here. I don't have an identity for cotangent, but I do have one for tangent, right? So I've got a power reducing identity for tangent squared. Cotangent squared is just the reciprocal of tangent squared. So I'm looking at the power reducing identity in the upper right hand corner of your formula sheet. I'm looking at the power reducing identity for tangent squared, and I notice that for tangent squared, it's going to be, it would be 1 minus cosine of twice this angle divided by 1 plus cosine of twice this angle. Twice this angle is just going to be x, right? And for cotangent squared, of course, I would just take the reciprocal of that. So I'm thinking cotangent squared x over 2 could be rewritten as 1 plus cosine x over 1 minus cosine x. Okay, again, I'm just taking the formula for tangent squared, the power reducing identity for tangent squared, and taking the reciprocal since I'm dealing with cotangent squared here. Okay. Oh, how boring. I think we're done. Right? We're trying to get it to look like this, and we're almost there. Like, notice that the numerator, if I just multiply the numerator by itself, I get the numerator here. If I multiply that same quantity in the denominator, I'm going to end up with 1 minus cosine squared, which is sine squared, right? Let's work it out to make sure that that's what happens. Let's multiply by 1 plus cosine squared, or sorry, 1 plus cosine x over 1 plus cosine x. I'm not even going to expand the numerator. I want it to look like this. So I'm going to say, all right, well, this is 1 plus cosine x squared, right? Squared over, I would get 1 plus cosine x minus cosine x, so those cancel, and then minus cosine squared. And then last but not least, we can get from here to here just by using Pythagorean identity, right? 1 minus cosine squared is the same as sine squared, and we're done. Okay. So that's it for that one. Some people might try to bust into our classroom here in a second. Do not be alarmed if we're interrupted. Let me see. How long has this video been so far? 4 minutes? I think we can do another proof on this video without it taking hours and hours to upload to YouTube. Let's prove another identity. Okay, so let's try out, this one looked interesting, so let's try it out. Sine 2x over 2 sine x. Oh, I think of something right away there. And then cosine squared x minus 2 minus sine squared x over 2. I'll give you a second, pause the video, see if you can work it out. Okay, so here I go with it. Well, what I notice right away here is I have a double angle formula for sine 2x. So I'm going to start with the left-hand side again. Okay, I know the double angle formula for sine 2x is 2 sine x cosine x. And then that's really nice because the 2 sine x parts just cancel. And I end up with cosine x. So the left-hand side of this equation just simplifies down to cosine x. Getting that to look like the right-hand side might be a little more challenging, but here's what I'm thinking. So I did some simplifying on the left-hand side. I'm going to do some simplifying on the right-hand side. If I can get the right-hand side to also be cosine x, then I've proven the identity, right? So let's do it. I think we can, right? I'm noticing a double angle identity there. Cosine squared x over 2 minus sine squared x over 2. That's just cosine x in one step. Yeah, that's just cosine x. Because, so remember you have that double angle identity. One of the versions of cosine 2 theta is that you could say it's cosine squared theta minus sine squared theta. So these angles here get doubled there, right? So if I'm starting with x over 2, cosine squared x over 2 and a sine squared x over 2, if I double that angle, right, if I double that angle, I just get cosine x. So yeah, well, so that was not very interesting as it turned out. But there it is, right? In fact, I'm gonna erase this and just complete my proof by saying, hey, by applying that double angle identity up there, oh well, then this is just cosine squared x over 2 minus sine squared x over 2. I should have recognized that right off the bat. I didn't recognize it at first, but there it is. By the way, it should go without saying, like, there's, as I've said before, there's more than one way to skin a cat. You could have come up with a completely different solution to this, which, you know, as long as you're getting to the right place with, and all of your steps are correct, I mean, that's fine, you know? Anything goes as long as it's correct, as long as it's true. Okay, how are we doing on time?